So we are going to discuss what is called rigid transformations. Now, let's first talk about the second part, transformation. A transformation is when something is either slid or translated, so we'll call it a slide. That's just moved over. Or something's rotated. Rotate, rotation, rotated. That'd be like this. Something's rotated. And the final one we're going to look at is reflection. Reflection is going to require a little more imagination right now, creativity. If we had small mirrors, you could do this yourself. Reflection would be like my hand here, my hand here. These are reflections of each other with the line of symmetry or the line of reflection between my two thumbs. We're going to go through this. So these are the transformations. Now, the other part to this is rigid. The rigid part's pretty important. So let me show you what's non-rigid. So non-rigid that's going to be like this. If I take a circle and I were to grab it and pull it this way and slide it across, it would shape something like that, right? Kind of like a teardrop, right? This is a non-rigid transformation. The math and the modeling behind that, not pretty. We're going to avoid that one for right now. If you go into the world of special effects, you will be addressing this. But for right now, we're going to skip that one. However, rigid transformations would be something like, let's take a kite, and in this case, I slide it, and it's the same. I'm going to put a little dot on here. Maybe I rotate it, and you can see it's the same here. Okay, both of those are rigid transformations because what I started with is also what I finished, except just moved. So let's take a look at how we use these. So I'm going to start with this shape. I like this shape for a lot of reasons. It's kind of like a golf flag. They have on golf courses where the hole is. And let's say I draw another one right here. Okay. Now my question to you is, how did I go from this shape to this shape? We're going to call this first one A, and A prime is going to be the second one. So how did I go from here to here? Now, hopefully you said, hey, that was just like your hands, where there's a plane of reflection or a line of reflection right between them. So that's right. So right here, this is where the mirror would go. Okay, that's my line of reflection. Now let's see how the points actually move with this. So I like to use the coordinate system. So I'm going to make this guy here, let's make this the y-axis, and we'll make this guy here the x-axis. Okay, and let's put some points on here. How will we call this one? Let's see. Go down a little further. I'm going to call this point 3, 1. And because reflected, it's the same distance away, this point here is going to be minus 3, 1. I can keep doing this sort of game. Up here, let's call this one 6 comma, I don't know, 9. Right there. Over 6, up 9. Well, if I went over 6 that way, it started over 6 over here. Okay. Now reflection about this line gives you this sort of relationship. Now what rule can I make? And the rule is going to be the formula for moving all of those points. Every point got moved by the same recipe. So let's take a look what this is. So when you write the rules out, it's something like this. It's going to be x comma y, and that's going to be my a. So I'll just emphasize it's a. And that's going to go to something else over here, which is the a prime. Now in this case, we went from here to here. So let's take a look. -3 goes to +3. -6, +6. What did my x value do? I went from x to -x. And my y in this situation is the same. So this is my rule for that transformation. So the rule for reflection about y-axis. Okay, this is the rule for the reflection about the y-axis. X goes to -x, y goes to -y. What do you think the rule would be for the reflection about the x-axis? What if instead we ended up down here? Okay. See if we can figure this one out. Well, my distance over here is the same, so -3. And instead of 1 up, I'm going 1 down. Okay. We can do this point right here. Same idea. -6 over. And instead of 9 up, 9 down. Okay. By the way, we're going to call this point, this shape, the double prime. That's the first one. This is the second one, just so we can differentiate them. So A to A double prime. And in this case, the x's are remaining, but the y changed values. Okay? Now we're keeping it straightforward by having the reflection about the axes. Once we start reflecting about lines out in space or at different spots in here, things get a little bit different. Okay. Okay, let's try another one. So let's go with my axes here, x and y. And in this case, let's go ahead and put one, let's put one right here on the axis. Okay. And I'm going to put the other one on this axis right here. where is my reflection line, my line of reflection? Well, I just gave it to you. It's at diagonal. So this time here, we are reflecting about this line. And if you want to be a purist, that's y equals x line. That's going to be might come into handy here in a minute. So let's say our point stopped. Let's just stop them right here. So not as far down as it shows. And let's see how this changes. Let's call this point here 0, 3. Well, for this one over here, this reflection, I am now 3, 0. So instead of going up 3, now I'm just going sideways 3. Let's try another point. Okay? How about this one right here on the nose again? And let's call that one, I don't know, so 3, say but minus 5, 8. Okay, so I went 5 and 8. Now over here, you gotta keep in mind, it's still 5 over, so it's 5 out from the nose. So this distance is still 5, and then this distance is still 8, because I didn't change the dimensions of it. So now this point here is going to be 8, 5, but it's going to be a negative right there. Okay? So negative 5 to 8. Now it's 8 to negative 5. Here it was 0, 3, 3, 0. I think we have enough to make a rule. I think the most illustrative one to look at is going to be these two right here. I went from negative 5 to 8, which also happens to be what my y was. Check this out. So now my x point is actually my y point, and my y point is now my x point. So reflection about this line right here follows this rule. Now, you don't need to memorize these rules. I never memorize these rules because you can derive them and figure them out. Every time you do this, you can throw some points on here. Hopefully it's on a nice grid. You can count and you can determine what the rule is. Sometimes you need to be a little bit clever and look for a pattern, but you look at the rule. Okay? You should be able to do this if it was the other axes over here. When x equals negative y, you're going to see a similar relationship. So this is reflections.